All right, welcome everyone. Last talk of the conference. Hopefully your brains aren't all too saturated at this point, and your attention spans are ready for one last talk here. So today we're going to be talking about using TypeScript with the ArcGIS API for JavaScript. My name's Nick Sanger. I work on the ArcGIS Online team. I also work on template apps and doing general, mostly front-end work around the platform. And I'm here with my colleague Jesse, who works on the ArcGIS API 4X, and he also works a lot on the typing. So he's a really good resource for anything related to using TypeScript with the JavaScript API. So jumping right in here, the first thing I'm just going to go over from kind of a high level some of the topics we're going to talk about. So first thing, we're going to look at what is TypeScript. Maybe some of you have heard of TypeScript, haven't really started using it, have heard it could be beneficial for your development team or for you as a developer. So we'll just take a look from a high level at what it is and what are some of the reasons why you might want to start using it, some of the benefits you can get from switching over to TypeScript from JavaScript or just jumping in with TypeScript. So we'll talk about some fundamentals, some of the basic concepts that you'll need to get rolling with TypeScript, and then after that we'll look at some more advanced concepts. These are things that you may not necessarily need just to get started, but they're good to be familiar with if you want to start working with the JavaScript API, and especially if you want to take a look at some of the source code that we put on GitHub for things like widgets coming out of the API. And there's some additional functionality from the API that you can really start to take advantage of if you get comfortable with TypeScript and some of these concepts. So then we're going to look at development tooling and setup. So I'm going to go over really quickly. We're going to keep it super simple, but we'll look at how to set up a developer environment using TypeScript. So pretty bare bones, but we'll get you up and running with JS API application using TypeScript. Then we'll look specifically at working with the 4X JavaScript API using TypeScript, some additional functionality you can take advantage of there. And then finally, we'll cover some of these core features of the 4X JavaScript API that are especially powerful when you use them alongside TypeScript. Some of them you even have to use TypeScript to take complete advantage of. So this is for the ambitious user that really wants to dive into using the JavaScript API the way we do internally. So first off, what is TypeScript? TypeScript is a superset of JavaScript. So TypeScript is transpiled down to JavaScript. So transpiling is another way, it's kind of a fancy way of saying compiling. So what this means really is we're taking TypeScript, we'll run it through a compiler, and in the end we just get normal JavaScript that hopefully everyday browser can understand. The reason we call it transpiling is because TypeScript and JavaScript are at similar levels of abstraction. So they're similarly distant from like the metal of the computer processor. And when we transpile TypeScript to JavaScript, we're going from one sort of language that's at a high level of abstraction to another relatively abstract language, JavaScript. Some of the advantages of using TypeScript are that we get all these nice ESNext features. So ESNext features are part of the ECMAScript language standard. So these are features that are going to be built into JavaScript and going to be built into browsers, but some of them may not necessarily have great support in all of the different browsers that our users may use. And so we can safely use some of these features by writing in TypeScript, letting the compiler transpile that functionality down to like ES5 JavaScript that all the browsers can understand, and then we can start using some of these things. So that's things like ES6 imports. You might have seen just the import line at the top of a module, arrow functions, object rest and spread, which we'll talk about a little bit later, AsyncAwait we're also going to talk about, and there's tons of other nice features that can help kind of tighten up your code and make everything a lot more readable and give you some functionality that otherwise might be kind of inconvenient to write. This one's kind of obvious, types. So TypeScript allows you to type out your code, which gives you some additional safety and helps keep things tidy and keep everything more maintainable. And then finally, I think this is a really important part of TypeScript, and it's part of the reason why it's become so popular over the last several years, is that it's completely compatible with existing JavaScript. So many of you have probably used or use everyday packages from NPM. The node module system has, or the NPM, the node packaging management system, has grown sort of exponentially. And this is a huge amount of functionality that you can just bring into your existing JavaScript code base. With TypeScript, you don't have to throw all of that away. So you get that in addition, and if you set some compiler flags, you can actually just use ordinary JavaScript and plug it right into the TypeScript compiler. Generally, we don't really do this if we're working with TypeScript, but that is a possibility. All right, so what are some of the benefits of using TypeScript? Well, we just went over a few of them, but I want to go into like some of the higher level benefits and maybe the reason why you want to get your team to shift over. So when I first started using TypeScript, or thinking about using TypeScript, I saw this logo. I don't know if they still use this, but it says TypeScript JavaScript that scales. And at the time, I had done quite a bit of work with JavaScript. I was pretty interested in the JavaScript scene. And so I saw this and I thought, I don't know how I feel about that. I'm kind of a purist, and I think JavaScript could potentially scale too. Why couldn't JavaScript scale? And I think a lot of users see this and they think, oh, this TypeScript, that's kind of highbrow. Why would I want to use this? We can write good JavaScript applications too. But TypeScript, it's going to be a little bit easier to scale your application because you have these restrictions enforced on you. And these restrictions are to help you from, help prevent you from writing unmaintainable code. So some of the benefits of this are that TypeScript's easier for multiple people to work on. And that's because if you're typing out interfaces, you have well-defined contracts between parts of your application, then it's easier for another developer to jump in and quickly understand everything that's going on. For the same reason, it's easier to refactor. If you have a really good understanding of the functionality of your application, if it's very well typed out, then you can change some piece of functionality, and you can be sure that you're not going to expose a bunch of different bugs for different edge cases and things like that. It's also easy to test, so we should be writing unit tests for our applications, and TypeScript makes this easier to do because, again, if we have well-defined contracts between parts of our application, it's easy to come in, cut something off from the bulk of our application, and put it under test. And for all of these reasons combined, this is sort of the penultimate goal. We can prevent the accumulation of technical debt in our code base. So technical debt is something that we want to keep as low as possible. If you accumulate a lot of technical debt in your code base, it's going to slow down the implementation of new features because you're constantly having to kind of look over your shoulder for whether some poorly defined global variable is going to essentially mug you while you're developing and prevent you from implementing what you're trying to do. So going into some fundamentals of TypeScript, let's start out at the very basics. So what TypeScript really adds on top of JavaScript is this ability to structure our application around these primitive or basic types. So some common ones you'll see, these are kind of the most widely used basic types are the Boolean, just true, false, numbers, strings, and then arrays, which are indicated by these brackets, and objects, which are indicated by the curly braces here. In addition to this, TypeScript provides another basic type, which is extremely powerful, called any. And while any is one of these sort of controversial things, I don't encourage you to use any because it's essentially just telling the TypeScript compiler, don't bother me. I know what the type of this thing is, and you can trust me to write this code without any bugs on my own. But any does allow you to take existing JavaScript implementations, and you can just attach any to it and plug it directly into a TypeScript code base. So if you run into a situation where you're porting a lot of code from JavaScript into TypeScript, then you can declare some complex piece of functionality in any, and the compiler won't bother you. Now, I want to warn you, it's easy to get carried away with this, and you can start just labeling anything any, and then really all you're getting from the TypeScript at that point is the transpilation. So you're getting those extra ESNext features, but if you call everything an any, you don't really have any type safety in your code base. And that's kind of one of the main reasons we want to use TypeScript in the first place. So here I have some examples of just using these basic types. I have this type foo, which is a number. And then I can make this const foo, which is of type foo, and assign it the number 8. And the compiler will ensure that foo is never anything other than a number. So I can be sure that foo is always going to be a number anytime I use it. Same thing for bar here. If I say that bar is a string, assign it a string, the compiler will make sure that it's never going to be anything other than a string. So you may have run into this situation in JavaScript before where you assign something a certain value, and then later on in your application, you're using that variable or using that function. You've kind of forgotten what exactly the type of that thing is, and this can produce errors at runtime. We want to prevent that using TypeScript. So here's an example of using any with this Waldo object. And this is kind of an example of what not to do and how you can get carried away with any. So I have Waldo, which is anything, and it's an object that has this do stuff function associated with it that takes these things, which are also anything, and it returns anything. So in this case, it's returning something, which is just coming from somewhere. I don't really know where it's coming from, and it could be of any type. And this is unsafe, so my colleague has helpfully added this comment, here be dragons, to indicate that we really have no idea what this thing is doing. So moving on, type inference is another way that the TypeScript compiler can help us type out our code. And this is just this idea that we don't have to specify what type every variable or constant is. So we just say let foo equal 8, and the compiler already knows that foo is a number. So if I reassign foo to 12, it knows, OK, that's a number, that's fine. If I try to assign it the string 12, then the compiler will yell at me and throw an error. So interfaces are another really powerful aspect of using TypeScript. And I'd almost go so far as to say it's kind of one of the driving forces when you're using TypeScript, is you can define these interfaces that are essentially composed of these basic types and use them to describe certain pieces of data in your application that you may be passing around between functions and the like. So for example, here I have my type foo again, which is a number. I also have my type bar, which is, again, a string. And then I'm defining this interface foo bar, which is composed of foo and bar. So it has this is an object with a property foo, which is a foo, or a number. And then it also has a property bar, which is a string. Then I can assign these constants, baz and quux, to be of this interface foo bar. And you can see in the first example with baz that I've assigned it an object that actually does implement this interface foo bar. So it has a foo property, which is a number, and a bar property, which is a string. And so the compiler's fine with that. Everything works out. If I now try to assign quux, an object that is not a proper implementation of foo bar, the compiler yells at me. So foo in this case is a string, so I get yelled at again. When you start using TypeScript, there's lots of yelling involved from the compiler, but you just kind of have to get over that. It's part of the process. Helps us learn. So interfaces facilitate predictable behavior in our applications. And here's an example of this. I have my interface foo bar again, and I'm going to refactor Waldo so that it's easier to understand. We can get rid of those dragons now. So const Waldo is an object. It has this do stuff function again. It takes things, but this time things are of the type foo bar, or they satisfy the interface foo bar, and it's going to return another foo bar. And you can see in my implementation of the do stuff function that foo takes that number foo and it increments it by 1. And it also takes the string bar and it just adds an exclamation point to it. This is using template literals. That's another really nice ES6 feature that just kind of shortens the amount of noise around combining strings. And then so I can take my Waldo object, I can call this do stuff function, and if I supply an object that satisfies the interface foo bar, then everything's OK. The compiler is fine with that. However, if I call it with arguments that are not foo bar, then the compiler yells at me again. And your IDE, if it has good TypeScript support, will even just show you that this isn't going to work. You have to supply a foo bar to the do stuff function. Expanding on this, we have this concept of classes. This is really an ES6 feature, but it's something that when used with TypeScript can be extraordinarily powerful. So I can define this class now, Waldo. Let's say I need more Waldos in my application, because I can never find Waldo. I never know where he is. So I'm going to define this class Waldo. It has this public do stuff function. Same implementation here. It's just going to increment that number by 1 and add an exclamation point to the string. But let's decide that do stuff was a little bit unmaintainable. I couldn't really understand what exactly it was doing. Now I'm going to split that method up into 2 private methods. I have this iterate number method, and now I have an add exclamation point method. And I've declared both these methods as private. Now I can go in and instantiate and create an instance of Waldo as test Waldo, and I can call this iterate number method with 2, expecting to get that 2 iterated to 3, However, now the compiler throws an error at me. It says, this method iterate number is private to the instance test Waldo. You can't call that from outside. And so this is another really powerful thing that TypeScript allows us to do is it gives us first-hand support for data privacy. So we can conceal functionality that we don't want people using from outside of this instance and prevent them from using it. Hide implementation details. So expanding on this, we have this concept of extension. Interfaces can extend other interfaces or classes, and classes can extend other classes, and they implement interfaces. So if I define this interface to describe a point, and I say it has two properties, x and y, each of those are a number, and then I can have another interface, point 3D, which extends the point and adds another dimension to it, this z-axis, which is also a number. Then I can make a class which implements that interface called myPoint and give it some default values. So we'll pretend that I want myPoint to be at the origin to start with. So I just say that it has x, y, and z equal to 0. I can extend that class to make a new 4D point by adding a time property. And it already has the x, y, and z because it's extending that existing class. So I can build these class hierarchies using TypeScript, which is extraordinarily powerful in object-oriented programming. So those are kind of the fundamentals, and that can get you really far using TypeScript. I think just adding these things to your existing JavaScript code can produce a lot of value. But if you want to go one step further and really type everything out, with these core concepts, you may have some trouble getting full type safety on all the functionality in your existing code base, or if you start a project, you may not be able to type out anything or everything. But using some advanced concepts, you can get pretty full type safety on your entire application. So Jesse's going to talk a bit more about what some of these advanced techniques are.
Thanks. Yeah, so just to give some context, in terms of TypeScript, when they started to get stabilized, basically TypeScript started with a pretty basic type system. They had all the classes, interfaces, and those kind of things. And then some of the newer things, they came a bit later, that advanced that type system to be more expressive and allow you to type more complex typings in your application. This helps a lot because it allows you to make, like, for me, the typings, they are kind of like tests, right? So that's kind of the first level of test that you don't have to write anymore. And the more complete you make your types, the better it helps you to structure your program and to also make sure that it's valid. So I will start with union types. So union types are, we put it under advanced, but it is pretty basic kind of concept in TypeScript, mostly because it's very common also in JavaScript that you have. So the idea behind union types is that it's not a single type, but it can be either one of a number of types. So here in this function, this is something that we have in the API as well, where you can set a size. You can either set a size as a number, which is interpreted as points, or you can specify a string, which is more like a CSS string, like 1 pixel. So this union type, which you indicate by a vertical bar, indicates that you have that this value of, in this case, variable v can be either this or that. And it can be more than 2 values as well. So intersection types, that's one that you may not have seen. If you're used to TypeScript, it's a bit more of an advanced type. It doesn't have as many use cases as a union type, but sometimes you can actually use these. And this is a pretty good example of that. We also use this in the API. It allows you, so instead of saying this is this type, or that type, this will say this is this type and that type, which means that it has the features of both of the types. So if you would have, let's say, one interface with a field foo and another one with bar, then the intersection of that is that it has both foo and bar. This is an example of something that you may also use yourself in JavaScript. It's very common to mix two objects together. So you take the properties of one object and you copy it into another. This allows you to actually express the resulting type of that. This also uses generics, which I will explain a little bit later. But the idea is that you can express that from these two input values that you have, the result will be the combined type. And this is pretty powerful. It's not used so often because if you use interfaces, you can also express this by saying, okay, I have this interface and it extends these other two interfaces, right? It's kind of the same concept, but you cannot dynamically, let's say, define interfaces as in this function, right? You couldn't actually express this. So type guards, I want to talk about type guards specifically because of union types. Type guards is, so TypeScript calls this type guards, and it allows you to narrow down a type if the compiler doesn't really know if it's one specific type. So when you have a union type like here, again, we have this v, which is either a number or a string. If you try to use that value inside that function, then you can only use stuff that is common to both of those types, right? So for example, in JavaScript, everything has a toString method. So this is something that you can do on that type. But if you want to add a number, for example, maybe that's not the best example. If you want to call like toFixed on the number to make it like a number of decimals, then the compiler will say, well, you can't do that because, I don't know, it could be a string and that doesn't exist, right? So type guards help you to narrow the type down to a specific one. There's a couple of built-in type guards, like typeof or instance of. So here, there's an example of typeof, and what this does is it will tell the compiler can now infer, if you checked for that at runtime, right? This is a runtime check. Now, at compile time, it knows it must have that static type, which is number. This also works with instance of if you use classes, so you can check for an instance and it knows it's that class. And the other one, another concept that you can use is tagged unions. So tagged unions, we use that quite a lot actually in the API. This makes use of something which is called literal strings. Literal strings, so we didn't really talk about that. They are a type, it's a bit like an enum, which has a string value. So it allows you to say, like use a string value as a type descriptor. In this case, so I think it will become clear if you read this. There's two interfaces here. One is foo, one is bar, and they have a type property. And I set it for foo, I type it, and so the foo string that you see there is actually the type of that field, right? And for bar, the type of that field is bar. What you can do then at runtime is if you just check for the value of that type, now TypeScript will be able to infer that it's of that specific interface. And this is pretty powerful because now you have this is kind of very natural thing to do in JavaScript, right? You tag something with a specific field that has a specific value, and then you can just check it at runtime. And this allows you to do that same pattern, but have a type safety, so to have type safety benefits to this pattern. There's actually other user-defined type guards. I don't show them here. If you can, this holds for anything that we're talking about. Really, if you want to know more, go to the TypeScript website, the handbook. They talk about all of this, and they explain it very well. So user-defined type guards, you can do that. If you're interested in that, then please look at the handbook. So generics, we've seen already some of my snippets that I showed use generics. So who here is familiar with generics? Okay, a couple of you, good. So for those who are not so familiar with generics, they work a lot like generics in other languages that support them, like C# or Java. Most of the statically typed languages support some form of generics. It's not like C++ metaprogramming, so it's not like C++ templates. It's not as powerful. If you're familiar with that, then this is not what it is. So you cannot do metaprogramming, stuff like that. But, so the idea is that it generalizes a type over a number of subtypes, and a common case is just having one subtype. A kind of easy, simple example is this list class. What I did here is a list, so there's a class list, and then I can specialize it with a specific type. What that means is then inside that list, I can now store items of that type. So I didn't really specify what type it is. I just say it can be a type, right? But all the items in there are of that type. And then I can write functions like this find function, which takes, so this is like your regular array.find, but type safe. So it says, it takes in f, which is a function callback, that takes in an item of that type that you specified, and then returns a boolean. If it returns true, this function that you give it, then it will return that item, which is of that type t. So down here, I have an example. So if you say, okay, I create a new list, and the subtype of that list, or the data that it will contain, is numbers, and then I will try to construct it with strings, it will say no. Okay, that you cannot do. Strings are not numbers. So you have to construct it with numbers. So it will type check this for you, right? If you wouldn't do this and you want to have a list class that can contain any kind of type in there, whether it's string or numbers, you would have to type it with any. And if you do that, you lose any kind of guarantees. And you can see here, down there, if I then do a find on that, it will actually infer the type of V inside that callback. So that's the thing that Nick also mentioned, like TypeScript is pretty good at inferring types. So it looks like you're just writing JavaScript. Like I'm not actually specifying that many types here, right? So that's also pretty beneficial to using TypeScript. So another one that Keyoff is a pretty advanced concept. It has been around not that long. I don't know when it was exactly introduced, I guess 1 or 2 releases ago. It's a really powerful thing. The use cases for Keyoff are a bit limited, so you might not have to use it or have any kind of need for it, but it's good to know about it. It allows you to make kind of dynamic types on the fly, in a sense. And I will first give you an example of something that uses Keyoff internally, and I will explain it a bit more. So one of the patterns that we use a lot in the API is when you can supply a function with options where all the fields of those options are optional. And then we have a set of defaults for every of those options. So here I made an interface which has options. I have 2 fields in it, should query and return geometry. And now I want to make my default options. In the default options, I want to ensure that I specified every single one. Sorry for the feedback on the mic. So what I do is I say default options is options, and that's to specify all those fields. If I would add another field to this interface, the compiler would tell me, oh, you didn't specify all of them in default options, right? This is what we want to do, this kind of guarantees. Now, in this function, which is called with options, I want that all of the fields of those options are now optional. Because we have the default options, we just need whatever the user wants to change of those defaults in addition. So TypeScript has this built-in type, which is called partial, and I will show you how this is implemented. Partial means that all the fields that are in options are now optional. And then what I can do is I use the spread operator. I don't know if you've seen that. It's also on ES6 or ES7. I don't know. ES6? Okay. Spread operator. So I say, okay, take all the default options and then mix in the options that come from the user, right? And this is all typed safely. So the way that they do it, so partial is a built-in into TypeScript. You don't have to implement this. You can just use it. But that's the way that they define it. And this uses Keyoff. So this is a pretty hard thing to read if you're not used to it. So don't worry too much if you don't really understand the syntax. It's not so important. What Keyoff does is you give it a type, and Keyoff will then result in the kind of the union of all the fields of that type as literal strings. And you can use this P in Keyoff T. Basically, P will take the string value of each of those fields. And so what you can do, and then you can define an actual type with it. So P in Keyoff T, in this case for the options, it will be this should query and return geometry. And then I can type it, so I use the question mark to make it optional. And then I say the type of that should be P, like the type of the field P inside T. I understand, when I say that, it's pretty difficult also for me to explain it like this. But the reason, the way that works is then the same as what you see here. So if I say type partial options would be partial of options, it's actually completely equivalent to writing this interface partial options where all of those fields are optional. There's a couple of other useful things you can do with Keyoff, but it's all based on the same kind of concept. We use that in the API in a couple of places. It really helps us to further make the type strict, where before we actually had to resolve to something which is very loosely typed. And it helps us in refactoring and everything. So give it a look if this interests you. The handbook talks about this as well, and it's pretty useful in certain cases. All right, so moving on to a couple of other things that are not really, that they're also syntax actually, but they are a bit more higher level things that you would want to use. So AsyncAwait, who here is familiar with this? Okay, just a couple, okay. AsyncAwait, so the nice thing about TypeScript, and I think Nick explained this already, but what they do is they don't really accept any features that they don't already know are going to end up in the next version of JavaScript, right? So they wait until the proposals are at stage 3 or 4, I'm not exactly sure, before they actually start thinking about adding it to the language. But then they're usually ahead of the engines, right? So they actually had AsyncAwait support before all the engines did. So that's kind of a nice thing. You can start using new features without the worry that they actually are becoming obsolete or that they will never end up in JavaScript. AsyncAwait makes asynchronous programming nice again. So if you know a bit about asynchronous programming, so before we used to always have callbacks, and so you had this kind of callback hell where you had to like nest all the way down, and it's really hard to follow. Now we have promises, they are a bit better, but you still need to like make .then change, and then it's not very readable either. AsyncAwait solves this by making your program read as a kind of linear sequence of statements again, while still being asynchronous. And TypeScript polyfills this to when targeting ES5, and I checked because I had a question on Wednesday if it does that for ES3, and it does so as well. And let's have a little look. I'm going to sit down for this because I need to do something with here. So is it this? Yeah. Or use the other one?
This one's good.
All right. So let's have a look at how you can use AsyncAwait. I made a small example that uses the JavaScript API for this. And it's a kind of like a simple thing. What I wanted to make is a function that makes an elevation profile. And so elevation profiles in the API, you can do this by querying the elevation service, and that's an asynchronous operation. You have to go to the service, get some data back, and then process it, etc. So the way we can do this is, so the first thing you have to do is to say, my function will be asynchronous. And you do this by using the async keyword. That basically, it does a bunch of stuff in TypeScript to let's say, to transform that function when it transpiles it down. But it also allows you then to use await inside that function. So what I do then is I just await here on this function that is actually asynchronous. All the asynchronous, like under the hood, AsyncAwait is based on promises. And they did this in part also because then it makes it very compatible with existing JavaScript code that might not use AsyncAwait internally, but it will actually return promises. So we don't use AsyncAwait everywhere in the API. We have some small places, but all our API is based on promises, which means that you can use AsyncAwait with all of our API. So what I did here is just await on that asynchronous result, and then I just continue. And you can see, and then here what I did, so actually this is densify. I did the asynchronous densify using the asynchronous geometry engine. And then I use query elevation, which is another asynchronous operation. And my program reads as if it was synchronous, right? Like this is all sequential. So it's much, much easier to follow the logic of your program if you use this. I think this is really, this is gonna help a lot by making the code much more readable. So if I would have the same, so this is a relatively simple function still, so but I think this is much more harder, like this is harder to read for me than the previous version. So this is the promise-based function. And you can see I can just use these functions haven't changed, but I can use them also with promise-based calls, right? So this is a very kind of opt-in thing. If you don't want to use this, don't do it. If you want to, then you can. So that's AsyncAwait. Have a look and get some more information. Google it. You will find out like how it works and how you can use it. There's plenty of examples and good resources on the web. All right, over to you, Nick.
All right, so now that you've heard some of the basic features and functionality of TypeScript, maybe you're interested in getting started with it. I just want to run through real quick how you can set up a development environment to get running with TypeScript and the JavaScript API 4x. So first, let's talk about some of the things we're going to need for this. So the bare essentials really are, for one, of course, you have to install TypeScript. And assuming your project's already set up with npm, this is really easy to do. So you just do npm install save dev TypeScript. And then depending on whether you're using the 4x or the 3x API, we have @types definitions available. So we have typings available for either version of the API. And same thing here, you can just install with npm install -- save dev @types / whichever version of the JS API you're going to use. Some tools that I recommend, though, are not absolutely essential for working with TypeScript are, for one, for your editor, I would recommend you start out with Visual Studio Code. There are some other editors that have good TypeScript support. I hear WebStorm has really good TypeScript support. I even know some people who use or try to use Vim for working with TypeScript, though there's going to be a lot of configuration associated with that. So I recommend using Visual Studio Code. They have really good TypeScript support, and they stay up to date with all the latest and greatest features associated with TypeScript. TSLint, this is kind of the TypeScript parallel of things like slint, JSLint, JSHint. So this will just keep your styling of your code consistent across your code base. So it's going to enforce things like how many spaces for an indentation and things like that. And it'll tell you if the code is inconsistent across modules. And so you can keep your styling very consistent there. I also recommend, especially if you're working with the 3x JavaScript API, that you install Dojo's typings. And this will allow you to get good type safety on all the functionality you're bringing out of Dojo. So the 3x API uses Dojo a bit more heavily than the 4x API does. It still could be useful in the context of working with the 4x API, but this will help you if you're trying to bring your whole code base into TypeScript. All right, so let's move on to setting up here. And we have a pretty good guide available for getting started with TypeScript and the JavaScript API on the developer's site. I'm just going to go over to that now. Excuse me, Skype is complaining at me again. So this just goes into detail about setting up a development environment to use TypeScript with the JavaScript API. And I'm just going to run through this really quickly to show you how kind of quick and painless it is to get started with TypeScript, even if you've never done it before. So let's see. First thing I have to do is get to the directory I set up for this. And set up demo here. OK, so I just have an empty directory here. You can see in the editor I haven't started anything. And the first thing I'm going to do is, oh yeah, does this expand here? Can everyone see the terminal? No? Let's see. Oh, wrong way there. Sorry about this, guys. How about now? Can you guys see the terminal? OK, cool. So first thing I'm going to do is just initialize a project with npm. So I'll write npm init. And I don't really care about what the package name is or who the author is or anything like that. So I'm just going to accept all the defaults here. And that'll get me started with a package.json. And you can see I don't have any dependencies yet. I haven't installed anything from npm. And I need to install those basic dependencies. So I'll do npm install save dev TypeScript. Wait for that to finish, and then I'll install the typings. So you'll notice I entered in -- dev when I added those dependencies. And the reason for doing that is that, for me personally, I like to keep separation between dependencies that I'm shipping down to the user, so things that'll be included in the actual product that I'm sending down, and then things that I'm just using on my machine for development. And both the typings and TypeScript itself are just going to be on my development machine, so it doesn't really have any impact on the final code that I'm shipping the user. That's going to be exactly the same as if I were just writing the whole thing in ES5. Plain old JavaScript, but in this case, I get the benefit of those future language features and strong typings and all that good stuff. OK, so now that we've installed our dependencies, let's just go back and check the guide here. The first thing they recommend doing is setting up a basic scaffold for your project. So I need an index.html. It's just going to be the entry point to my application. I'm going to need a tsconfig. And this is what's going to tell the TypeScript compiler everything it needs to know in order to build my application properly. And then I'm going to put the TypeScript itself in this app directory. We have an entry point called main.ts. So for the HTML, there's a little bit of script tags and things that you need in order to get working with the JavaScript API. So I'm just going to copy and paste that in directly from the website. You can see it just says basically where my application is. It's in app main, loads the JavaScript API. And this is extremely hard to read. I apologize for that. And it does some configuration with the Dojo loader so that it knows essentially where my application lives. Next thing, we can write our first file in TypeScript here. When we're writing TypeScript, all of our files will have the .ts extension or .tsx if we're using JSX. We're not really going to get into that during this talk, but if you're working with developing widgets, then you're going to be using the .tsx extension. So I'm just going to copy and paste this really basic mapping application into my editor. So you can see all I'm doing here is importing Esri map, and then I'm importing the map view. Then I'm going to create a new map with the streets base map, and then I'm going to create a view of that map centered on a particular location. The next thing I have to do is set up the tsconfig. And again, I can just paste this configuration directly in here, and it will work fine. But we'll go through these properties so that you kind of know what a handful of them do. So the first thing, this is really important, is the module format. So we're telling the TypeScript compiler what we want the resulting JavaScript to use as its module system. And in this case, we're going to use AMD. The JavaScript API uses AMD exclusively for its module loading, so we have to use AMD when we're working with TypeScript here. There are some exceptions you may have seen in the frameworks talk. There are some ways to sort of get around this if you need your application to be in a different module format. Again, we're not really going to get into that in this talk. There's a lot of information on that available with respect to working with frameworks and that sort of thing online. I'll set no implicit any to true. There's a few of these options that you can set in the tsconfig that just encourage the compiler to be as strict as possible. And I'd really advise you to use as many of these as you can, especially when you're starting out. You want it to start off strict so that you can learn all these things and type your code out very strictly at first. And then if you find that it's just too much of a hassle, you can start sort of lowering the intensity of the compiler. But keep in mind, you're also not getting as great a type safety if you're removing options like this. So what this actually means is if I don't add a type to something, then the TypeScript compiler will actually complain at me in this case. Whereas if I set this no implicit any to false, then it will just assume that if I haven't applied a type to something, then it's an any. Source maps, I'm going to enable those. This just means when I'm debugging in the browser, it will tell me where in the source code the bug originated, as best it can. And if I don't set this to true, then it's going to show me where in the transpiled code the exception was thrown. And this is generally not very useful because the transpiled code, while it is somewhat human readable, we would prefer not to look at that transpiled code as much as we're looking at our source code. JSX, we set that to React. Like I said, we're not really going to get into JSX or TSX at all in this talk, but we need to use React for this setting. That's just how it invokes the function that it does when it runs into JSX in your code. So the widget framework does use some of this JSX. And then we have our own sort of in-house JSX factory, and that's the function that actually gets called when it encounters some JSX. Our target's going to be ES5. You can see if I hover over this that there's several options, ES3, ES5, and so on and so forth. I'd encourage you to just use ES5 for now. ES5 has pretty consistent implementation in many different browsers, so you can know that when you transpile your code down, it's going to run in most browsers. Your users are going to be happy. They're not going to run into unexpected behavior if they're using some obscure browser, hopefully. And also, you'll find if you use ES3, it's going to bloat your code a little bit more because it has to do more work to transpile down to ES3 since it can't use any of the ES5 features. Experimental decorators, we need to set these to true when working with the JavaScript API. We'll talk about decorators a little bit more later. And then the rest of this I'm not really going to get into, except for this include. We need to make sure that the TypeScript compiler knows where the entry point to our app is. All right, so now that we have that set up, the last thing I want to do here is create some NPM scripts. We're not really writing any unit tests in this demo, so I'll get rid of that test script. I'm going to make a build script, and what this is going to do is just run the TypeScript compiler. And I'm also going to make a watch script, and this will run the compiler in watch mode. And what this will do is when I change the source code, it'll just automatically recompile. And this is really nice if you're just trying to make a quick change and see the results in the browser right away. So open up my terminal again, and now I can run the build script. And assuming I set everything up correctly, this will produce a main.js corresponding to main.ts, my source code. You can see this is just ordinary ES5. It doesn't look particularly pretty. It's using some things that we may not ordinarily use in our JavaScript. But the main idea is that we don't really care. The compiler took care of this for us. And all we have to really worry about here is the source code. And it'll make sure that everything behaves properly in the transpiled code. I'm going to go ahead and run my watch script. And so this will recompile when I change the source. And let's just go take a look at what this demo looks like here. You can see this is just a really basic, about as simple as it gets. I'm making a map zoomed into Los Angeles. Now, if I go back and remove the zoom property, all I'm going to do is hit save here and reload. You can see I'm zoomed all the way out. So I didn't have to go run the compilation step again. It's just watching the source code and automatically regenerating that transpiled code. So I can really quickly set up a development environment and see the changes really fast.
One of the other things that's really great about the watch, it integrates very well with Visual Studio Code. So it will automatically run it, and if there's any errors, it will highlight them. You can jump to them and stuff like this. And it's also much, much faster. So if your code base starts to grow, watching is kind of the only way to keep your productivity happy. We ran into this with the JavaScript API. It takes like 20 seconds or so now to compile, I think, the whole thing. But with watch, it's nearly instant. So yeah, keep an eye out for that.
OK, so I'm going to turn it over to Jesse now to talk about more specifically working with the JavaScript API and some of the cool things you can do there when you're using TypeScript.
Thanks. So let's look. So working with the API, so we have the typings out there. Those are public typings. It works more or less like any other regular typings, but there are some small things that you might want to know about. Some kind of requirements or things that you need to do in a particular way. So as you know, Nick mentioned this, the JavaScript API is currently strictly AMD. This does mean, so the way that we export the classes that you're used to in JavaScript is that when you import the module, you get the class back. This is not actually really how ES6 imports and the module system wants you to do that. But AMD was done before they actually settled on kind of like the system that they wanted to promote as an ES feature. And so conventionally, classes are exported directly. We need to keep that this way to make kind of to keep this backwards compatible with the existing code that you have. And that means that right now you need to use require to make your import. So you cannot really use import map view from, for example. Except, so in the most recent TypeScript release, which was done, I don't know, exactly a couple of weeks ago or a month or so, there is a new option which is called ES module interop. If you enable this in your package, in your TS config, then you can use imports which use default, like the default imports from ES6. This is very recent, so I tried it out, it does work. If you are really so there's no real benefit to this except that your imports can be all looking the same. Because for TypeScript, this doesn't really matter, right? It will generate exactly the same code. But if you are want to keep your imports completely consistent or you care about this, there's now an option to do that. Autocasting, if you know the JavaScript, so who of you knows already the JavaScript API for ArcGIS JavaScript API, sorry. All right, the rest of you are just interested in TypeScript in general. So there's this concept called autocasting, which we use to cast up from a kind of object literal to a specific class. This is very useful in JavaScript, so you don't have to import all the modules necessarily when you use this. But in TypeScript, we cannot actually correctly type that concept. It just doesn't fit the type system. What we would need to do is to have different types for the getter and the setter of a specific property, and TypeScript just doesn't allow you to express this. So when you set properties, unfortunately autocasting is not available. You will have to just import the modules. The only place where we do support autocasting, and it's also already maybe 50% of the cases, is in constructor signatures. Here we actually do allow it, so you can have just plain objects, and we do correctly type that as well, so it's completely type safe. We did a couple of typing improvements since the last year, so we're always actively working on our typing support. We are using our public typings ourselves also for other projects, which is a good way to make sure they are correct. We now use generics where possible, so this helps a lot if you use collections to make sure that all the methods return the subtypes. We strictly type events on the views, so you can, in the event handler, you know what kind of fields you can access on the event object. And we do more advanced autocast like colors, for example. So before you couldn't, you always had to kind of pass in an actual color, and now you can also pass in strings, and for screen sizes, it's strings for indicating like a CSS style screen size. So that's within constructors, right? You can do this now. One of the most common requested one is base map. So you couldn't really do, like when you say new map and then base map equals streets. So that's something that we allow. It's like the streets definition, so it will create that base map. You couldn't actually do this in TypeScript, but now you can. So we always appreciate a lot if you find stuff that doesn't work with the typings, please report it. You can report it to the JS API resources repo on GitHub, and then we'll come back to you and figure out if it's a bug on our side. So we generate the typings from JSDoc, and that's why sometimes if the documentation is wrong or slightly off or doesn't document the types correctly, the typings might be incorrect. But I think by now we're getting really good at full coverage of the whole API. With correct typings. Advanced API concepts, so I realize that I'm running a little bit late. Is it okay for everybody? Do you want to continue, or you can just walk out also, of course. That's fine. But I'll take the liberty as the last session of the day to continue a little bit. So promises are always a little bit of a tricky thing. Especially with TypeScript and things like AsyncAwait, because we use promises that are based on Dojo promise, right? If you know the API a little bit. This is because native promises were not a thing when we started to develop the API or when Dojo was made. At this point, native promises have settled down. There's a full spec and everything works the same in all the browsers. Not all the browsers support native promises, of course, but that's you can kind of polyfill them if you want to. One of the biggest changes, and you might have seen this in other talks, is that we replaced .then with .when for Esri core promise. This is an important thing to realize. Right now, there's still kind of a backwards compatibility mode, but this will go away in the future, in the near future, actually. If you want to know more about that, there's guide pages on the SDK that explain why we needed to do this, why this is important. It's all in terms of making our promises compatible with the native promises and make the API work with native promises if you want to use them. Typings for promise are more compatible. They're not yet, we cannot really make them fully compatible, unfortunately. We tried really hard. We spent quite some resources on that, but it's just not, it's not completely possible. But it's much better, so you will need much less kind of casting or wrapping. But if it does happen sometimes, and the general advice is to just wrap the promises one way or another in the different types, so yeah. Writing accessor-based classes. So this is a little bit advanced. This is really not required in any way, except for if you want to do custom widget development. But it can be helpful. It's the way that we write our applications. often. So we use Accessor, properties, and watches. If you want to use that same concept in your app, and this is completely optional, obviously, then you can also do that in TypeScript. So our classes still use Dojo declare. If you're a bit familiar with the API, that is something. So, and that's where it kind of gets a bit hard. So what we wanted to do, and we kind of pioneered this inside the API, is to use TypeScript and classes that you define in TypeScript, but at runtime, we need them to be compatible with Dojo declare classes. And I will show you how this works. It uses a whole bunch of kind of more advanced TypeScript things. So it's okay if you're not fully comfortable or completely understanding what's going on, but I'll try to explain it. So I have an example here. These things, they will be on GitHub as well, like all these snippets and examples on the slides, so you can look at them later. So there's a couple of pieces that come together to make this all work. So this is kind of a magical thing to do, to create these classes that are defined in TypeScript, but actually end up being Dojo declare. I will show you how we managed to do that. So the first piece, and that's something that you might not ever have seen, there is something in TypeScript where you can define an AMD dependency that you actually, it appears that you're not actually using in the code, but it's there underneath and it will include it in the final result. So TypeScript has something that is called helpers, and these helpers allow it to actually implement the things that are not in ES6. So, or in ES5 or in the target, like in the module that you're targeting. And so what these helpers do is things like extends, for example, that's how they implement that. And you can provide your own helper if you want to. And one of the ways to do that is using this AMD dependency. So we're saying, well, and the special helper is called __ extends. So that's what it uses at runtime to make class extensions. And we say, well, in this file, use the one that we provide. And this is a special one that is we call it declare aware. It does some special things to make it a declare class. So that's one thing that you need. The other thing that you need is a couple of decorators. Decorators are a concept that also exists in other languages. I think it's most similar to decorators in Python, if you know Python. What it does is allows you to kind of manipulate things at runtime when the file is being run, when it's basically being defined. So what this does is, if I use this subclass decorator here, and what I get is, at runtime, it will actually define this class just the regular way that TypeScript will do, and then we'll pass that class into this decorator, which is a regular TypeScript function. And then my TypeScript function can actually do something to that class to manipulate it in a way, and then the result that it returns is then the actual class definition. So this allows you to dynamically at runtime do kind of things to that class to manipulate it or transform it. And that's what we use to actually, so what we do is we pick apart the class, we take out all the fields, all the methods, all the static methods and stuff like this, and we then use Dojo declare to actually construct a new class from it. And that's how we kind of bridge the two systems. So this is, it should be obvious to anybody, this sounds really hacky and pretty nasty, and it is, but it does work. We use this in our API. It was really the only way that we could start using TypeScript without having to rewrite our whole code base, which is hundreds of thousands of lines of code. So it was really the only way that we could start using TypeScript. Our ultimate goal, obviously, is to get rid of this. This is not something that needs to stay, but that requires us to move away from Dojo declare, which is a kind of large project. We're continuously thinking about how to approach that. So I hope we'll be able to get to that. So this then defines a subclass. There's one more piece to this, which is called. So there's a special way in TypeScript where you can kind of define base classes based on the result of an expression. I will not explain it in full detail. You can also look at the handbook if you're interested in understanding all of this. We have a special function which is called declared. The thing that this does, it does a couple of things, but the most important one is that it allows you also to do multiple inheritance. For multiple inheritance, you can use this to basically specify multiple base classes. I would advise that you don't use this, but I put it out here. If you do have a use for that, then you can do it. It's sometimes useful to have multiple inheritance, but in general, I would advise against it mostly because native, like ES6 classes don't really have this. I don't think it will come also, and it does complicate your code. It makes it a little bit less readable, but it is possible using Dojo declare. It's not very future-proof because we would like to get rid of Dojo declare in the long run. So I discussed multiple inheritance. There's, I think, one last thing that I would briefly want to touch on, which is type extensions. So we have had, it's becoming less and less prominent, but sometimes like people came to us and they say, well, these typings that you generated, they are not correct for this and this specific case or this and this class. And so what they did is people tend to just edit the typings file, right? So, and just to give you an idea of why we generate this typings file. So if I go down here, it's like 60K lines. So this we don't want to maintain by hand. It also includes actually all the public documentation inside this file. So you can see this is something new, actually. Sorry, this part is not where. So this is where basically we define all the properties, etc. We copy in all the documentation, or at least the first paragraph. So you get IntelliSense in editors that do support it. For example, if you try to autocomplete the base map definition, you get even the screenshots of the little base maps and stuff like that. So it's pretty cool. This is new from last year. I don't know. I think we landed this in 4.6 probably. So I was talking about extending this. So people would just edit this file, and then when you need to update it, it's kind of cumbersome because you would have to somehow keep your changes and stuff like this. You could probably use Git for that. Another way to do it that people may not know necessarily is that you can also add typings onto existing typings by extending them. And what you can do is you can declare the namespace Esri __Esri, which is our internal namespace. You can just declare it again and add some typings into it. Here I made an example where query elevation is not actually strictly typed. We use a union type for both the input and the output. So you pass in a point, and it's typed as if what comes out is either a point, a multi-point, or a polyline. And so then you would have to kind of cast it again yourself. What you can do is you can actually override the typings here, and you can make it more specific. So obviously this is a kind of case where we basically take the feedback and say, well, obviously we want to type it correctly, so we are going to work on that. But in the meantime, if you want to enhance the typings a little bit, that's a good way to do it. So you don't modify the actual typings, just define it on top of it. It's not always possible, like you cannot remove stuff, you cannot completely replace things, but you can enhance certain things like that. So with that, that's I guess all the things that we wanted to say. So a little bit of basic stuff, a little bit of advanced stuff, working with the API, how to get you started. Look online, look in the SDK, it's all explained there. Of course, if you have questions, ask us. And I think it was a great conference for us. I'm happy also that it's over in a way, right? I don't know about you guys, I'm pretty tired after yesterday. So yeah, any questions? You want to add something?
I just want to suggest everyone, fill out the survey if you can. That really helps us improve if we do this talk again next year. And also, if you want to see any of the demos and slides from this talk, they're all available at this link. So in this GitHub repository, there's all the demos we showed, the setup. And there's additionally some things we didn't talk about. So if you're interested in working with a framework like Dojo or something like React, I have a couple directories in there, just basic projects that are set up with TypeScript, and one's with Dojo and one's with React. So that can give you just like a bare minimum setup if you want to work with those tools in combination with TypeScript and the JavaScript API. So yeah, we'd be happy to take any questions if you guys have them.
So, yeah. So I can talk a little bit about what we did for the JS API, and I think it worked out very well for us. So it really depends a little bit on your use case. If it's a small application, maybe you can afford like doing it from scratch. If it doesn't take too much time and you can like do it within a cycle or something and still add maybe some features, that sounds like a good idea. It is a little bit easier, I would say, and it helps your design in a sense if you start from scratch. Because if you started implementing things in JavaScript, what you'll have often is that you use paradigms or patterns that actually don't really fit within the TypeScript world, but you couldn't express it with types. You're doing things like having like an object that is of a certain type and just adding properties onto it just for like because it's convenient. At the same time, if you want to stay productive and kind of, because this is an internal refactoring that like your customers don't really care about, right? So for the JS API, what we did is really starting like piece by piece. And this works very well with TypeScript because any JavaScript is valid TypeScript, like Nick explained. It's a strict superset. So we started just, and we're still in the process. We have converted around 80% of our code now to TypeScript. But it's very, very nicely working together in a hybrid way. Using any of the JavaScript from TypeScript, you will have to start writing type definitions. So that will speed up. So any of the dependencies don't have to necessarily be in TypeScript, but you have to define type definitions. Those type definitions could be as easy as just saying, well, this is of type any. Like that's where you can get started. So I think they did a really good job in TypeScript to allow people to incrementally start using it and not kind of like block your development process for I don't know how long to try to convert the whole thing in one go.
I'll just add to that. It depends to some extent on your existing code base and how that's structured. So if it is relatively decoupled, not everything is depending on everything else, then it may be easy to just cut something off, a small portion of it, and rewrite that in TypeScript. But depending on how your code base is structured, it may be harder or easier. Like Jesse mentioned, you can import JavaScript directly into TypeScript. So you can just start writing new modules in TypeScript. But you may find that at the start, at least, it may make things a little bit more complicated if you have this kind of different build step for a small portion of your code base. Yeah, you'll just leave that running while you're editing your files. But between, before I would say commit changes, I would probably just run the build without watch, depending on how you set it up. A lot of people who use other tools that have watch, like Gulp or Webpack, you may be slightly different. You may do kind of some different things in the compilation step, depending on whether you're doing the regular build or watching. But yeah, you would generally just leave that running. Sorry, the editor? Oh, that's this console emulator called Commander. It's a Windows application. It's very similar to Git Bash. I use it effectively exactly like I would Git Bash. But it looks cooler. Yeah, in most cases, you're just going to be able to use the TypeScript compiler to get all that ESNext goodness. There are some instances, I think, where Babel may allow you to get things that are even more experimental. So TypeScript, and Jesse, you may know more about this, but they kind of decide which features they're going to incorporate into TypeScript for transpilation. And I think it's things that they're pretty confident are going to make their way into the language. Whereas with Babel, you can sort of specify, like, this new thing I heard about that sounds really awesome, I want to use it today. And then you have to watch out, though, because that may not actually make it into the language. So you can get attached to something that ends up not really being very future-proof.
So TypeScript will, so the polyfills that it generates, like for example, for await async, it will actually generate it inside your code. So there's no external dependencies out of the box. I'm a little bit unsure about this, but that there's something that they're doing now, which is, I think, so the thing what they do is in every single file, they will include this kind of snippet that is the polyfill, which kind of blows up your code size for nothing. And so they're doing something by creating what they call, I think, TSLib. I don't know if you know a bit more about that, Nick, but I think that's where they are now putting those helpers in because they're getting kind of too large. And so that's, I think, something that you would then have to include at runtime beforehand. But I think that's all opt-in. So right now they will just generate everything. There's nothing that you need to do in addition. Your code will just run once you compiled it. Any other questions? All right, then thank you very much for listening and have a nice end of the conference. Have a good trip back to wherever you have to go back to. See you next year, hopefully.
Thanks, everyone.